Hello everyone! This video will give you a little bit of instruction on how to use your oscilloscope. First, let's start with what the oscilloscope is used for. We will be using our oscilloscope to examine how voltages in our circuit change with time. We'll use it to look at input signals, mainly from our function generator, output signals, and all of the intermediate signals in between. Let's first take a look at how we should appropriately use the probes for the oscilloscope. So this is our oscilloscope probe. We have our ground connector and then the probe itself. These little spring tips you can pull down and it will expose a little hook. You can connect that to a wire, or if you're going to be probing a component, you can pull these off very carefully to expose this little point here. Make sure you do not lose these little spring tips. It's better to use the spring tip because you can attach it to a small piece of wire, and now it won't go on. So what I like to do is put the spring tip over the wire, and then the ground connection of your oscilloscope probe must always be connected to the ground of the circuit. For me, that's this blue rail down here. I'll then take the probing end of the oscilloscope probe and place it at the output of my signal. Now we will look at how we can use the oscilloscope to actually see the signals within the circuit. There are two different axes on the oscilloscope screen itself. In the horizontal direction, we are looking at time steps. So each little square of that grid corresponds to a unit of time. You can find that time measurement right here up at the top of the screen. Right now, we are seeing 50 microseconds per little square of the oscilloscope screen. The other dimension, in the vertical direction, is used to look at voltage. Again, each little square on this grid corresponds to one little step in voltage. You can see what each step in voltage is by looking up in this corner. Right now, we're looking at 100 millivolts per little square of this oscilloscope screen. As you can see, our signal isn't very interesting right now. All we see is noise. Part of this is because we're looking way too close to the signal. We are far too zoomed in time. To adjust the time step per division, we use this knob here. So first I will turn counterclockwise to increase the amount of time per division. This is what the signal looks like at 50 milliseconds per division. And now we are at 2 milliseconds per division. As we can see, the signal is a little bit wiggly here, so we'll go ahead and increase to 10 milliseconds per division. Usually we want to try to fill the entire oscilloscope screen with our signal. To do that, we can adjust how many volts per division we ask the oscilloscope to display. To do that, we will use these knobs here. You can see this oscilloscope has 4 different channels, the yellow, green, blue, and red channel. Since we're looking at the yellow channel, I will use the top knob to adjust the amount of volts per division that is displayed. And now we can see much more of the signal. This lower knob is used to adjust the ground offset of the signal. If we look over on this left-hand side, there's a small little 1 next to a ground symbol. That shows us where the ground of the signal is being displayed. If I move this knob, I'm able to scoot the signal up or down. This can be very useful for aligning your signals. Now, I'm displaying the input signal to my circuit. If I want to look at the other probe, probe number 2, I can push the green button, 2, to turn the signal on. You'll notice that the green signal has now appeared on the oscilloscope screen. I'm going to go ahead and make the yellow signal slightly smaller so I can get a better look at the green signal. Again, if I want to increase the amount of time per division, I'm going to rotate this knob at the top to the left. If I want to zoom in time, I will rotate to the right. And I can adjust the voltage per division using the top knobs and the ground offset using the bottom knobs. There's one more important feature that we need to look at when trying to display signals on the screen. There is a concept of a trigger, which is controlled by this knob here. If we look to the left side of the screen, there is a line here and a little arrow with the letter T, which stands for trigger. You can think about these signals as being infinite in time. It's a sinusoid, but it continues indefinitely. In order for the oscilloscope to display something that's easy for us to understand, it wants to pick a constant point to show in the same spot, so the signal doesn't move all over the place. It can be really useful to change how you're triggering in order to make the signal sit still. You can see here it's wiggling quite a bit, and that's because our yellow channel, the T is yellow, so it's looking at the yellow channel, our yellow channel is a little bit noisy. In order to change which channel we're triggering on, I'll go ahead and push this button that says trigger, And if I look down here at the lower end of the screen, I can push the second button that says source and change it to source 2. Now you can see that the signal is much more stable because channel 2 is much less noisy. You can use one channel only to trigger, and you can also change that type of trigger, but we'll stick with this for now. The last thing we're going to look at is how we can use the oscilloscope to measure amplitudes and frequencies. To do that, we can look over here in this little measure box. One of the most useful tools is what's called a cursor. If I push this button, and the buttons do push in, if I push this knob, I can bring up a tiny little menu. Let's say I want to measure the amplitude of my signal. First, I will pick the Y1 cursor by rotating the knob and pressing it again. And now I can take this orange line that you see at the bottom of the screen, I can take that line and place it at the bottom of my signal. You can also use this cursors button to select your cursors. If you press the cursors button, a menu like this will appear at the bottom of the screen. You can change your cursor by pressing the third button. I'm now controlling the Y2 cursor. I'll go ahead and move it down to the top of my signal. And now over on the right hand side, you can see that the oscilloscope has done some math for you. The delta Y on channel 1 is about 71 millivolts, which is pretty close to the actual voltage that we assign to the signal using the function generator. You can also use other measurements by pushing this measurement button. When you push that button, you can add different measurements so that they show up in the quick measurement side of the screen. Simply push the second button, and you can use this knob here to select whichever type of measurement you would like to use. Let's say that we would like to use a peak-to-peak measurement. I would push this button in to select, and then the peak-to-peak measurement of my signal 2 has shown up over here in the quick measure. Sometimes you'll have 4 already and you want to remove them. You can press the clear measure button, and you can clear either all of them using clear all, or whichever measurement you no longer wish to have, and then you can add whichever measurements you need. You can push this button to change whichever channel you're looking at, and this button changes the type, and then you click to add.